Hey there, everybody. Today's class, we are going to go over reactions and equations, specifically balancing equations. All right, so let's get going. A little introduction to reactions and equations. Just as a reminder, we've talked about chemical and physical changes before. Specifically, we're going to bring back up chemical changes. And just remember, when we rearrange atoms from one substance to a different substance as a chemical reaction, it also might be referred to as a chemical change. Okay, so this is, we're going to go through a couple of examples of how we know a chemical reaction has occurred. The first thing that we're going to look for is evolution of energy as heat and light. So for example, a temperature change. So you can see in my little diagram over here, I got temperature changing from hot to cold. Another example would be a color change. So you can see in the diagram, again, a little GIF of the different colors. A third thing would be production of gas. So in our GIF here, you can see how gas is being formed in this reaction. And usually you can see a odor, or if you don't specifically see a gas, you might also see an odor. And then the fourth thing is a formation of a precipitate. So you can see that example down here. Basically what we have is we have a solution, another solution gets mixed in, and then you can see a solid that's formed in the bottom, and that's what a precipitate is. So when we see a chemical equation, it's usually written in either symbols or a formula, and it's going to identify the molecular and molar amounts of the reactants and the products in a chemical reaction. And each statement is going to include two different parts. The first thing is the starting substances, which are known as the reactants. The second thing is the substance that is formed in the reaction, which is known as the products. And when you see this, these examples of chemical equations, you can see them in various ways, and these are just three examples. You can either have a reactant to produce two products, you can have two reactants to produce one product, you can even have two reactants and produce two products. So there's various ways that you guys can see these things written. The format for these things, though, is always, for this class, reactants on the left and products on the right. When looking at chemical equations, it is important to know what each of these symbols represent. So over there on the left is a list of different symbols. It's important to take a few minutes to kind of look at those things and kind of commit them to memory because you're going to be seeing them a lot. And just a couple here, you can see that the positive sign or the plus sign is going to separate the two reactants or products. A arrow pointing in the one direction means it yields or forms. A double-headed arrow is a reversible reaction. S or CR, we most likely are going to see the S, but in some texts you might see CR. It just identifies that it's a solid. An L in parentheses is a liquid, a G is a gas, and AQ is aqueous. And remember, an aqueous substance is something that has been a solid that's been dissolved in water. The triangle indicates that heat has been reacted. Word and formula are used to describe a chemical equation or reaction. So word equations, obviously, you're going to use words. So for example, sodium plus chlorine produces sodium chloride. Now, when you actually read this out loud, the way it's supposed to be written is solid sodium reacts with gaseous chlorine to produce sodium chloride. So those little subscripted letters there, the S, G, and the S, again, that just indicates what state it is. You can also see them written as a skeleton equation, and a skeleton equation is going to use the chemical formula. So for example, Na plus Cl produces NaCl. All right, so when writing these skeleton equations, it is important to remember the rules of writing chemical formulas. So remember, if these things are ionic compounds, you have to check the charges. So for example, if I just wrote out magnesium chloride using words, most people are just going to put Mg and Cl together. But remember that Mg has a +2 charge and Cl has a -1 charge. So you have to do MgCl2. So again, it is important that you remember how to write the charges. That stuff doesn't go away. So another thing to notice when doing some of these chemical equations is you might run up on something called a diatomic molecule. And that's because these atoms exist in nature as two of the same atoms covalently bonded together, and there are 7 of them. So you need to memorize these 7 different atoms. So hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Again, these are called diatomic molecules, and they exist as a pair of covalently bonded atoms together. Okay, so if you see an equation, it might say hydrogen plus oxygen produces water, which you'll see down here at the bottom. So remember that it's written as H2 because you got 2 hydrogens together, plus oxygen, and 2 of those because, again, they don't want to be by themselves, produce water. So again, commit these 7 atoms to memory, write them down on a separate sheet of paper, but again, these are called diatomic molecules, and they always exist as a pair. All right, so let's add a couple of examples here. It says transfer the following word equations into a skeleton equation. So we see we have magnesium bromide as an aqueous solution plus chlorine gas produces magnesium chloride aqueous plus bromine gas. So again, these things are ionic compounds, so before I start writing anything down, pull out the periodic table and maybe polyatomic ion chart, because again, we're going to have to be able to write those things correct. So you can see I have magnesium bromide, which is written as MgBr2 aqueous, plus chlorine Cl2. Remember that chlorine is a diatomic molecule, so it has to exist in a pair, and it produces magnesium chloride aqueous plus bromine gas. And again, bromine is also a diatomic molecule, that's why there's 2 of them. For the states of them where I have AQ, G, AQ, and G, I wrote them down because they're written down in the problem. It's nice to know what state they're in. If you didn't write them down, I'm not going to take off points for them, but just understand why they're written there. Number 2, it says we have metallic iron plus aqueous copper 2 sulfate reacts to form solid copper 2 and solid iron 2 sulfate. Now, when I write this problem, iron by itself is a solid plus copper 2 sulfate as an aqueous solution. Now, a mistake that a lot of people make, they say, wait, it says iron 2. Remember that iron and Roman numeral 2, that 2 is there because it represents the charge on iron, okay? Remember, the Roman numerals represent the charge, so that's important, okay? So it's going to produce copper plus iron 2 sulfate. And number 3 here, it says transfer the following skeleton equation into a word equation. We have aluminum plus bromine produces aluminum bromide. So when I write this out, we have solid aluminum plus bromine as a gas produces aluminum bromide. All right, so for the big portion of what we're going to talk about today is balancing chemical equations. And whenever we have an equation, all these things must satisfy the law of conservation of mass. And remember that in the law of conservation of mass, things can't be created or destroyed, okay? So whatever you start with, you're going to have to end up with the same amount on the other end. So to ensure that the law is satisfied, all chemical equations must be balanced using coefficients, the number written in front of the reactant or product. Okay, so we're going to use coefficients to balance these things out. So coefficients are whole numbers and are not written if the value is 1. So if it's a 1, you can leave the blank empty. Coefficients must always be in the lowest whole number ratio. So let's take a look here at our first example. We have H2 plus Cl2 produces HCl. Now notice that we have 2 hydrogens on the left and 2 chlorines on the left. All right. So one thing that I always do whenever I do these kind of problems, there's no good way that I can sit here and say, okay, this is the best way to balance this equation, or this is a trick to balancing equations. I just kind of use a guess and check method. Now this one's really easy because we have 2 hydrogens on one side and 2 chlorines on one side, and we have HCl. We have them both on the other. So very simply, all I need to do is put a 2 there. Okay? That's all you got to do. All right? So now, again, you can double check. I got 2 H's and 2 Cl's on the right, 2 H's and 2 Cl's on the left. All right? The arrow is going to be your divider from reactants and products. Looking at our second example, we have zinc plus HCl produces ZnCl2, and H2. Now, another way that you can do this, if you can't just do a guess and check, you can kind of put a divider up here in the arrow, and then I would write down what you have. So you might have Zn. You have Zn on both sides. You have H on both sides. And you have Cl on both sides. So you can make a chart or a table. This might help some of you guys when you're balancing, especially when you get to much more challenging problems. So currently I have 1 zinc on the left, I've got 1 zinc on the right, I have 1 H on the left, I have 2 on the right, all right? I have 1 Cl over here, and I have 2 over here, okay? So I see that my zincs are good, so I'm not going to mess with those. My H and Cl is together over here, so if I change that and I put in a 2 there, you now see that I can cross that out, and I cross that out, so I have 2 over here and 2 over there, and I'm balanced. All right, so the best way to do these things is to do a bunch of practice with them. Like I said, there's no secret, there's no tool I can give you to show you a different way that says, oh, this is the best way to balance this, this is it's a trick or anything like that. It's all guess and check, or you can do what I showed you just a second ago and just make a table. Again, I don't have any tricks. I do have one for a certain type of problem, but we'll get to that in a minute. So let's look at the first one here. We have sodium plus chlorine produces NaCl. We have 1 Na on both sides, and we have 2 Cls over here and 1. So the first thing that you might want to do is you might want to to balance your Cls. If you do that, now you have an unbalance with your Nas. So I'm going to put 2 NAs and then 2 in front of the NaCl. Again, notice I don't put anything in the Cl blank, even though it is just 1. So again, you can just leave that alone. For the next one, I have aluminum plus bromine produces aluminum bromide. Now, if you notice here in the products, you have AlBr3. Well, nothing times 2 and 3 can't go into each other. So you got to use the lowest common number that they both go into, which would be 6. So if I do that, I'm going to put a 2 in front of the aluminum bromide, a 3 in front of the bromine, and then, of course, a 2 in front of the aluminum. So again, the more you practice, the more you see little things like that. I wouldn't really call them tricks by any means, but they're just ways to kind of practice these things. So again, here in example number 3, what we have is we have NH3. We have 3 H's, so maybe if I put a 2 in front of the NH3, that gives me 6 H's, so I'd have to put a 3 over here in front of the H2. And there we go. Okay? Again, no real tricks, it's just a bunch of practice. All right, so for this last 4 problems here, I'm going to let you guys practice those, and I want you to try them on your own before writing them down. So what I want you to do is pause the video, try all 4 on your own before you actually listen to me. So again, pause the video. I'm going to keep going just for the sake of time and keep the video short, but go ahead and pause and try these on your own. Okay. All right, so number 4 here, we have NaOH plus CaBr2 produces CaOH2 and NaBr. All right, now in this problem here, what you might want to do, and you can't do this all the time, but you kind of have your OH on both sides, and you don't have H's or O's in any of the other things, so you might want to kind of keep those together if you're making a table. So when you do that one, you might want to have Na as one thing, OH as one, and you can do that with polyatomics. You can't always do it, but you can do it if it's the same on both sides. Okay, so those can be your 4 things on your left and the right. All right, so let's go and look at how we can balance this one. and all I needed to do was put a 2 in front of the first one and 2 in front of the last one. All right, number 5 here. This is probably the only one I can kind of give you a hint on, or a trick on, I guess you could say. Whenever you have a combustion reaction, always do the O2, always do this one last, okay? Always do that one last. If you do this one last, hopefully usually works out. I usually start off by looking at the H2O. I have two, and the reason I look at the H2O first is because this O over here is by itself, and even if I don't ever touch that, that's still going to have to be, I'm going to have to make that into an even number because nothing times 1 is going to give me an even number over here on the left side. So I can start off by putting a 2 there. And if I put a 2 there, that means I got to put a 2 over here in front of the C2H2. And then I can go from there. All right, that's really the only trick I have, and it's just for combustion. So again, for this one, what I would start with, me personally, I start with the H2Os, and I'm going to have to put some kind of even number in that blank, just because nothing times 1 is going to give me an even number over there. The next one I have SnSO4, so tin 4 sulfate plus potassium phosphate produces tin 4 phosphate plus potassium sulfate. Again, if you have this one, try to keep your polyatomic ones together when you make your table. Don't try to balance them out separately. Like, for example, leave the SO4 together. Don't break up the O's between that and phosphate because you have sulfate and phosphate on both sides. So I got 3, 4, and 1, and then the 6. All right, the last one, number 7 here. We have barium chlorate. Let's see, we have chlorine, oxygen, and barium. So again, remember this 2 on the chlorate side, that means you have 2 chlorines and you have 6 oxygens. So all you need is a 3 there. All right, that's all I have for today. Again, guys, I don't have a ton of tricks or anything like that. It's just going to be a bunch of practice. I will take a ton of questions tomorrow if you have them, but just try to go through and do your best with balancing equations.